This video is for capacity of weakly symmetric channel. This particular example, we have 2 inputs and 3 outputs. So for example, 0, 1 and 0, 1, 2. And the matrix looks like this. F 1 over 6, 1 over 3. And notice that rows are permutation of each other. So distribution for given in the input are the same. So we can immediately say the second part, right? So capacity is maximum of input distribution Px entropy on y minus entropy on y given x. Since for each x the distribution is the same, so the second part can be written immediately as entropy on distribution. Okay, and then we can focus on the entropy on the output. Entropy on the output, the maximum is log 2 of the alphabet size, which is 3. So this is the upper bound of mutual information. Can the equality achieved? If equality achieved, is what is the input distribution? So again, using the symmetry, we can use uniform input distribution, and then we can show that this will achieve the equality. So by using the symmetry, we can do that for the case cases that column sums are equal to each other. So for example, let's say we find this probability pi and 1 minus pi. So what is the probability that y is equal to 0? So that occurs with pi times 1 over 6 plus 1 minus pi times half. Okay, and this one is obtained by pi times half plus 1 minus times half, right? Pi times 1 over 6, sorry, 1 over 6. And 2 is pi times 1/3, 1 minus pi times 1/3. Okay, so if here we put pi is equal to half, then we note that it is a half. Oh, sorry, half times 1 over 6 plus 1 over 2, half times 1 over 6 times plus 1 over 2, half times 1 over 3 times 1 over 3. So this, each one of them are column sums in each cases, and then these column sums are equal to each other. So basically in this case it is 6 over 2 plus 2 over 6 plus 2 over 6, which is 4 over 6, and this one 3 over 6, 3 over 6, this is 3 over 6. So it is 4 over 6. So all the column sums are 4 over 6, 4 over 6, all of them. So they are probable. So basically each one of them, the probability is 4 over 12, 4 over 12, 4 over 12. So they are equiprobable. All right. So the uniform input distribution gives you maximum mutual information, and that is nothing but log 2 of 3. And this one, given the channel, the conditional probability, this is determined. So this part is a number. And so we have done the maximization. So that's the expression for the mutual information. For the capacity, it has to be log 2 over 3 minus entropy on the conditional distribution. So that has to be the capacity. So don't leave the maximization sign for expression of the capacity. So this should be the capacity. Okay, that's the capacity of weakly symmetric channel.